Okay, now let us actually calculate limits of sequences. Limits of sequences. Before we calculate anything, let me say this theorem first. Theorem. It's the uniqueness of the limit if the limit of the sequence an exists, then this limit is a unique number. Then it is unique. Okay, it doesn't really help you compute the limit, but the next one gonna be more useful. Let me say theorem. This theorem says that suppose you have two sequences, and the limit of the first sequence is a, and the limit of the second sequence bn is equal to b, and where a, b are some real numbers. Then we will have the following. The first result say that if you compute the limit of the sum, right, an and bn, then it would just be a plus b, so you just sum their limit. This is called sum rule. Second one, you can subtract them. Now you do an minus bn, and you're gonna get a minus b. This is called difference rule. And the third one say that you can multiply each term by some constant k. Say to bn, you're gonna get k times the limit, which is b. This is called constant multiple rule. The next one talk about the product. So the limit of an times bn is gonna be the product here, a times b. This is called product rule. And the last one, now we have product, now we have quotient. It say that the limit of the quotient an divided by bn is equal to a divided by b. But be careful here, it's only true when b is not 0. This is called quotient rule. Okay, let's now use this 6 result here to compute some limit. Problem. This problem asks you to find the limit of the sequence 5 divided by n squared. Okay, how do we use the theorem? Well, we first write 5 divided by n squared equal to 5 times 1 over n times 1 over n. And I call this an, I call this bn. And then we know that an converges to 0. And that's 1 over n. That's easy, we know that. bn is also 0, converges to 0. So by the product rule and scalar multiplication rule, the limit here is going to be equal to 5 times the limit of bn, the limit of an. This is my an, right? Times the limit of an times the limit of bn. This is bn. So 5 times 0 times 0. So it's 0 here. Okay, good. Let's call this the first one. Let's look at another one. This problem asks you to find the limit of 4 minus 7n to the 6th divided by n to the 6th minus 3. Okay, how do we compute this? The first thing we will do is to simplify the fraction, right? Let's write 4 minus 7 n to the 6 divided by n to the 6 minus 3. It's not really simplified, but we divide both top and bottom by n to the 6. Right? The bottom also divided by n to the 6. This doesn't change anything. So it's 4 minus n to the 6 divided by this number. And the bottom can be n to the 6 divided by n to the 6 plus 3 divided by n to the 6. So simplify further, that's 7, right, divided by 1 minus plus 3n to the 6 divided by n to the 6. Okay, now this is my an, this is my bn. Do we know what an converges to? Yes, right? It's easy, right? That's minus 7, because 4 divided by n to the 6 just go to 0, right? And bn is also easy, it's 1, because so the limit here is equal to the limit of the quotient, right? Is equal to the limit of the top, which is an, divided by the limit of the bottom, bn, is equal to minus 7 divided by 1. That's minus 7. There are many techniques for computing limits of sequences, but we will only talk about a few of them. Okay, we will only talk about a few techniques for computing limits. So the first one that we're going to talk is called the sandwich theorem. Another one, we're going to use L'Hopital's rule. Remember, this is pronounced L'Hopital's. The third one, we're going to use a theorem called monotone convergence theorem. Let's look at the first technique, the sandwich theorem. Let me just say the theorem. Theorem. This one is called sandwich theorem. It says that if you have 3 sequences, an, bn, and cn, and you have an less than or equal to bn and less than or equal to cn, right? For all n beyond some index capital N, and if limit of an is equal to the limit of cn, say equal to L, then the conclusion is that the limit of bn must be the same, b equal to L, right? Here's a problem. This problem asks you to compute to find the limit of the sequence is minus 1 to the n times 1 over n. Here. We want to know what the limit of this is. And the first thing we notice is that minus 1 to the n divided times 1 over n is less than 1 over n. Right? Because, and also less than minus 1 over n. This is because the minus 1 to the n here just alternating between minus 1 and 1, right? So we have this. So I call this one an, call this one cn. So let us rename this sequence bn so that it agrees with the theorem. So now you see that we can apply the theorem. Do we know what the limit of an and cn are? Yes, we know. Right? We know that limit of an is equal to the limit of 1 over n, right? But times minus 1, so it's 0. It's also equal to the limit of 1 over n, which is cn, right, which is equal to 0. So by the theorem, the sandwich theorem, the limit of bn must also be equal to 0.